students, I welcome you all back onto this channel. So as you know, IIT has actually released the official key of GATE 2023 exam yesterday, and as far as engineering sciences is considered, XE basically here. So we know that we have launched official this keys based on the master question paper for XEB fluid mechanics, XED solid mechanics, and also XEE thermodynamics. And I on behalf of Team Dona is happy to tell you that XED and XEE is 100% correct. All 44 questions, XED 22 and XEE thermodynamics, all 44 questions what we have given is actually completely correct. Okay, but anyhow, as during the master question paper key time, we have told there is one question discrepancy in fluid mechanics, and that question is nothing but this hydraulic turbine question actually. Okay, so when we have solved this question, we have given the answer as 8 because we told that there is some ambiguity in the answer in the question actually. And at that time I told you, if you assume heads as constant, then you will get 8 watts. But IIT ने जो आंसर दिया कि which is 430 to 460 watts. Okay, so 430 to 460 watts. Okay, so how this answer is achieved basically, what is the ambiguity at that time we are talking about is, normally when we are solving this question, we have for any hydraulic turbine, any hydraulic machine, actually if you see, there are 5 important dimensionless numbers that governs the performance of the turbine actually. Okay, those numbers are basically these numbers: P by rho n cube d power 5, where n is the rotor speed, d is the diameter, density of the fluid, p is the power generated. Okay, and q by n d cube, normally if you perform simple Buckingham analysis, this we have told at a lot of places even during crash course and all. So gh by n square d square, and mu by rho n d square, and this is bulk modulus by rho n square d square. So these are the terms these are the 5 dimensionless terms which are important for any hydraulic turbine. So normally in practical cases, in actual practical cases, what happens is basically here, if you see, these 2 terms don't play much impact, because when we are talking about hydraulic turbines, compressibility effects doesn't play much, and also viscosity effects also we don't consider generally, because the head, which is basically the GH term which is actually available, plays a major important role. Okay, but in the question it is given that G is neglected. Okay, any gravitational effects is neglected. So here practically, in actually if you see conceptually, or what do you say, practically this term mu by O n square d square is actually negligible. Okay, it is negligible. बट IIT ने एक क्वेश्चन ऐसे फॉर्म किया कि हम इस टर्म को कंसिडर करना चाहिए. ओके, सो बेसिकली हियर first of all, anything is common. For power we have to consider this term because this is the only dimensional term that involves power. But we at that time when we are doing the analysis, we have neglected this G. But since potential head is completely neglected, means basically G is completely neglected, this term IIT एक क्वेश्चन ऐसा बनाया कि they have neglected this term, and theoretically, practically, we generally neglect the Reynolds number because we don't take any viscous effects into consideration. But here, if you see this mu by rho n d square, okay, so theoretically we cannot actually eliminate this. Okay, because theoretically when you do the analysis, you got one term. So IIT ने solution दिया कि जो this number की basis पे. Okay, so mu by rho n square d square. So now if you, in question they mentioned that, assuming, if you see the question, a hydraulic turbine with rotor diameter 100 mm produces 200 watt of power while rotating at 300 rpm. Another dynamically similar turbine, but when you are talking about dynamic similarity, generally these viscous effects are very small practically, so we generally neglect them. But in theoretical approach, you have to consider definitely this term here, which is mu by rho n d square. Okay, so rotates at a speed. Consider both the turbines to operate with same fluid, identical density and viscosity. So here they intentionally has put these words identical density and viscosity, because here this is the only dimensional number which involves mu and rho actually here. Okay, so between model and prototype, if you now equate this dimensionless number prototype, if you equate this dimensionless number, if you equate mu and rho, then n of model diameter of model square should be equal to n of prototype diameter of prototype square actually here. Okay, so you want the power calculation, so power of model by rho n model whole cube into diameter of the model whole power 5. So this should be equal to power of the prototype divided by rho np or cube into dp whole power 5. So basically here you want what is the power that should be produced by the second turbine. Okay, so let us suppose if you are actually modeling, because general turbine speed is 300 rpm and this is 200 watts. Okay, if you take P1 P2 for example, then N1 D1 square is equal to N2 D2 square. Okay, So here, if you want to calculate P2, for example, P2 is equal to P1 into density is anyhow common. So this gives you N2 by N1 whole cube into D2 by D1 whole power 5. This relation for D2 by D1 is actually achieved from this particular value. Okay, so N2 and N1 are actually given to us because first turbine is rotating at 300 rpm and second turbine is rotating at 1500 rpm. So N1 by N2 is 1 by 5. Okay, so N1 by N2, which is 300 by 1500, which is 1 by 5 actually here. Okay, so here if this is 1 by 5, then this value is equal to D2 by D1 whole square. Okay, so this is D2 by D1 whole square. Clear? So this value is D2 by D1 whole square. So if you replace here, then we get P2 is equal to then P1. So what is the power developed by this particular turbine? It is generating 200 watts. Okay, so 200 watts into N2 by N1 whole cube. So N2 by N1 is actually 5. So 5 whole cube is 125. So this is 125 into D2 by D1 whole power 5. So D2 by D1 is this 1 by 5. D2 by D1 whole square is 1 by 5. So this is square root of 1 by 5. So when you do power actually 1 by 5 whole power 5 by 2. Okay, so this is 5 by 2 and this is 5 cube actually here. Okay, so this is 5 cube. So if you simplify this calculation, you will get some answer in watts actually, and that answer is turning out to be around between 430 to 460 watts. Okay, so we shall do this question also. That could be better because anyhow we have done the calculation. So let us see if you solve this particular question. Okay, so 5 cube into 1 by 5. 1 by 5 is 0.2, 0.2 power 5 by 2, which is 2.5. Okay, so this is 2.5. So this gives you 0.017 multiplied by 125 multiplied by 125 into 200. So this gives you around 447.2 watts. Okay, so 447.2 watts, for which IIT ne answer diya ki 430 to 460 watts. Okay, so practically normally when as if you see hydraulic turbines, we generally don't consider this term because the viscous effects are way less, but theoretically we can actually, since we get that term, so IIT ने एक question form किया कि on the basis of this dimensionless number, which is actually the Reynolds number. Okay, so this is the only question which have discrepancy because at that time practically we generally eliminate this term. So हमें solution दिया कि on the basis of head, but actually on the basis of head, this particular value, the answer was given. Okay, and basically why we cannot challenge this is because practically anything can happen, but theoretically since we are getting one of the dimensionless terms, so we have there's a chance that they can consider this. Okay, so that's what. So this one question we have little discrepancy of the complete XCB, XCD and XCE. So I hope you all got very good marks when you have counted the official key based on the official key, and of course the official key has replicated almost 98% of the key that is given by Team Dona actually. So I wish you all get good ranks and waiting for your results. Thank you.